Here we have a cylinder with a bump on it. The suggestive contour version of this drawing is shown here. If we draw each line as a different color, the suggestive contours are drawn in blue and the contours are drawn in green. Using our classification scheme, we see different colors for the different suggestive contours. The red line here denotes a Category 4 line, those that extend a contour but do not intersect a ridge or valley, and the black line denotes a Category 1 suggestive contour, those that do not extend a contour, do not intersect a ridge or valley, and deviate from a parabolic line. In the original implementation, a universal threshold was used. In order to get rid of the Category 1 line, we must move up the threshold accordingly. However, this leads to a problem where changing viewpoints can bring this back, and additionally, other information about the suggestive contour that extended the contour has been lost. Using the categorization scheme, we have individual thresholds for each one, as well as the option to not draw them at all. In this case, we wish to get rid of the Category 1 lines. We can uncheck it, and changes in viewpoint will not affect that drawing. The categorization scheme requires knowledge about the entire line. This allows us to add additional functionality. Look at the image of the face here. We can see a bunch of these lines are caused by small deviations in the texture, either from the scanning in of the marble surface or due to noise itself. We would like to get rid of most of these. Under the original version of suggestive contours, as you increase the threshold, you can get rid of some of these. But even at the highest point, there are still those that will remain, and you've lost a lot of detail before. Thanks to the classification scheme, we can institute a minimum length threshold. Any suggestive contours that do not go through a certain number of triangles will be excluded. Here we can increase this minimum length threshold to a desired value. You see that most of the noise has disappeared without any loss of important detail. There are still some points that need to be thresholded out, but we can also look at the various labels to see which ones we might need to tune. The same can be applied to noisier versions of the mesh. Here, we end up with almost the same amount of detail maintained, but now there are a few extra lines caused by the noisiness of different suggestive contours coming together to extend past the range. In practice, as long as these are less than the important features you wish to maintain, you can get rid of them, but at some point the noise can cause the suggestive contours to be longer than the important features, and other thresholding may be required. By classifying suggestive contours, we can combine them with other line definitions to make even better line drawings. Here is the suggestive contour drawing of the screwdriver. We can increase the threshold for the bad suggestive contours and apply a minimum length threshold so that we now have the important suggestive contours of the screwdriver. Now, if we wish to add ridges and valleys, we can do so, and by upping the threshold, we get a very good drawing. The extra line along the shaft differentiates where it's going from a planar to a cylindrical shaft. The valley denotes the boundary between the shaft and the handle, and the ridge along the base of the handle gives a more well-defined shape.